Have you ever wondered why ChatGPT knows so much about everything? Or when you're actually typing a question into ChatGPT, what is going on behind the curtains? What is going on when you actually write something? Who are you actually talking to and how does this work? Well, in this video, we're gonna go from 0 to 100, everything you need to know about LLMs. In particular, we're gonna look at two videos from Andrej Karpathy, which is probably the most famous and one of the best AI researcher of LLMs in the world. But if you do not have so much time to invest in these two videos, which I suggest you to still look, in this video I'm gonna give you a summary of those and everything you need to know, again from 0 to 100. This video will give you all the tools that you need to have in order to really understand how AI works. In fact, we're going to look into all of the major steps that are needed for LLMs to work, from pre-training to supervised fine-tuning and finally reinforcement learning, in my opinion the most interesting part. So without further ado, let's jump right into it. First, let's start with pre-training. The first step of pre-training is to download and clean the internet. In fact, you may think this is going to be a little bit of a crazy and hard process to do because the internet and web is huge, but actually it's not that crazy. In fact, what we want to do is to end up with a big gigantic text file of a one-dimensional sequence of text. So really just imagine it as a note file when you open your Windows laptop. It's really just a text and it's not even that much. In fact, although the web is huge, we really are gonna filter it heavily and clean a lot of raw data. And indeed, what we're doing here is take the whole internet, extract only the text, so no images, no computer code, nothing but text. Then we're gonna filter a lot of websites because we don't want all the websites. For example, we don't want malware websites and we don't want spam websites. There are many websites we don't want. Then we can apply many other more filters, like for example, find web is an already downloaded and cleaned and filtered dataset of a lot of data from the internet. You will find it in the description. And what it did is essentially taking raw data from other websites, cleaning them in all of these ways. The major one are URL filtering and text extraction. Then also language extraction and language filtering is also a big one because we also want only English and not Spanish, for example. At the beginning, models were like that. And then really simply at the end of the first step, what we get is just one simple text file, a note file, very big. You can imagine it like that. The second step is tokenization. In fact, now we have a big file, a big text file, but the thing is that AI doesn't really read text. So what we're doing here is to convert text into something that is computable by AI, and that is tokens. We go very briefly from bits to bytes to token. It's not important, but the point here is that this big file that we downloaded, which is the internet, just text, a lot of text that represents the internet, has to be translated into a big file that is still just a long sequence, but not of text anymore, of tokens. Here, for example, on Antique Tokenizer, you'll find the link in the description. You can play and write whatever you want here and find that for everything you write, there is a corresponding token that is represented by this. This is the actual token. It's essentially an ID that represents a real text. In this example, how is represented by the token 4438. And as you can see, as you play with it, you will find that it's not as one word is one token. Tokens are really decided randomly. You can really play with the ticket tokenizer and you will see that tokens kind of feel like they are randomly generated. It's not as one word is one token, but that is really not important. What is important here to understand is that first step, we downloaded the internet into a one big single long line of text, and then we're going to translate this into a single long line of tokens, which are IDs that represents text. The third step is neural network training. We're gonna later see briefly what is a neural network, but for now let's try to understand what we want from this third step. Essentially, once we have tokenized this big long file of text, we want to feed it into the neural network so that the neural network can actually understand what is the most likely next token to come into the sequence. So for example, what we want to do is, given this line of tokens, let's say given these first three tokens, what is the most likely token to be the fourth token? In this case, 144 0. You can picture this as a giant autocomplete function that, after reading millions and millions of text, can start guessing what comes next. So again, in this example, let's say that there are these 4 tokens and the next 5th token in the sequence is 3962. Well, we're gonna feed into the neural network only these 4 tokens, and let's see what he guesses is the correct next token. So for example, this token has a probability of 2%, this token 1%, and this token, the correct one, only 4%. So what is going to happen as we continue to iterate this process is that this 4% gets up to, let's say, 6%. But before moving to the 4th step, let's actually see what is inside a neural network. Picture this, a giant black box filled with the dials and switches. These are the parameters, or the weights. Billions of tiny numerical weights fine-tuned over training. GPT-4, for example, has 1.74 trillions of them. The point here is that these models aren't just randomly guessing what's the next token. They have parameters and weights which are all inside a transformer. This, for example, is an image of a transformer, and all of these are the parameters and weights that get tweaked and changed a little bit every single time that the neural network is trying to guess the next most likely token. The inputs of a transformer are all the previous tokens, or a bunch of tokens, a sequence of tokens. Inside there are all the parameters and weights, which are mixed into this big gigantic mathematical expression to then try to guess the output, which is the next most likely token. Now, once we finish training the model, this is quite nice because let's say that the model can guess the correct next most likely token, i.e. the correct answer, all of the time. Let's say it's a very good model. The point here is that so far we are just guessing. The only thing that we have to do now is to create new data, so the next token. To do that is all just a matter of probabilities. We feed into the neural network one token or a combination of tokens, and then we simply take the most likely token to be the next one. The only difference is that now this is a new token that is generated by the neural network, whereas during the training we were giving the neural network the correct answer so that he could learn how to guess the next token. And now it's actually doing that, guessing the next token, the most likely next token. So again, the difference is that this is just new data, all new data. And the output that we get out of inference is the base model. And this is the end of the first step, but let's try to zoom out before moving to the second step. Pre-training is where AI goes from knowing nothing to absorbing a vast amount of information from the internet. We start by scraping and filtering the internet, keeping only high quality data and information, and then breaking these texts into tokens so that it is readable from our AI. Next, we train the neural network so that it can learn patterns. And we know it's not just doing that randomly, but it's using parameters and weights to trying to guess what is the statistically most likely next token. Once the neural network had learned how to predict these patterns, we finally get to inference and create new data. So now we have an AI that can spit out text and predict what's the next thing that will happen if I write something. But it really just sounds like a parrot reciting the internet. We can't really ask him anything. For example, if we ask him 2 + 2, he's not gonna tell us, oh, that's 4, but he's gonna tell us what's the most likely token to come next. So it's gonna look at the internet, and what happened most of the times that he found on the internet 2 + 2. So he sees that when someone asks 2 + 2 on the internet, something else happened, like an article, then he's gonna spit that out. He's not just gonna say 4. So how do we get from here to an actual useful assistant? Well, this is the beginning of the second part of the video, which is post-training. And the first post-training that we're going to look at is a supervised fine-tuning. This is where the personality of the AI really comes in. You can think of a fine-tuning as giving the AI some training wheels. Here, there are literally human experts at companies like OpenAI or Anthropic that manually create a lot of conversations of ideal prompts and ideal responses to those prompts. Essentially, they give responses to questions that you may ask to the base model, effectively teaching the AI what the right answer should look like. So a big company is gonna hire a lot of people that create a new data set of this conversation, prompt, question, and answer, ideal answer. to really create a new data set of conversations. And once we have this new data set of conversation, we continue to train the model just exactly as we did. In fact, there is no difference into how we train the models, if not in the data set, so the data we use to train the model. Before it was the internet, and now is these conversations. So for example, before, when we ask what is 2 plus 2, an actual human assistant is gonna say it's 4, and then the conversation keeps going. What if instead I want to multiply? Then it's still 4 because it's 2 times 2. Again, many experts that creates these conversations. The last thing to mention about these conversations is that humans don't really do all the heavy lifting of writing every single prompt and answer question and answer question and answer, because it really would require too much human involvement. Another very important thing to mention before moving to the third step is this illusion that this is an actual assistant. So far, for example, if we ask what are the best 10 landmarks to see in Italy, what we get is not really a real assistant that goes out in the internet and try to understand what are the 10 best landmarks to see in Italy. What is happening here is that the AI model is trying to give me a simulation of what is the most likely answer that a human labeler, which is a physical expert, tried to give to an answer to a question, that is similar to this one. So this model has been trained so that when someone asks what are the 10 best landmarks to see in Italy, a physical person typed down and looked around in the internet, okay, there is the Colosseum, the Pantheon, and many other things, and this is what we're gonna answer then if someone asks what are the 10 landmarks to see in Italy. It's not a real assistant, it's just a simulation of humans writing answers to pre-made prompts. So really your assistant, your AI assistant so far is nothing but a well-rehearsed actor performing a role that has been scripted by a lot of conversations, a data set of millions of conversations. So at the beginning, when we try to answer who are we really talking to when we write a question to ChatGPT, well, the answer is that these 10 landmarks that we can see in Italy are just a statistical imitation of the most likely response that a human expert that train the model would give. So the AI, the LLM, is not really thinking, or at least for now. So now let's move into the third and last part of this video, which is reinforcement learning, also a part of post-training. As we said, the answers we're getting so far are nothing but simulations of an answer that an expert gave. But now let's imagine as if this could actually be an assistant that can go out and think on its own and give me a new way of thinking about a problem. Essentially a problem solver, a real one. Well, this is exactly what reinforcement learning does. But first, why do we need reinforcement learning in the first place? Well, again, let's try to zoom out. In the first part of this video, we saw pre-training. We can really imagine that as a simply background knowledge. I get a lot of information from the internet as an AI, and now I know a lot of stuff. Then in the second part, we try to teach the AI how an expert would treat all of this knowledge, what he would do with all of this knowledge. It's as if we demonstrate how to use this knowledge so that the AI can imitate what an expert would do. But now in reinforcement learning is the moment where the student, the AI, can actually practice and learn. Okay, but how does it do that? Reinforcement learning is really nothing but trial and error with learning loops. But let's get directly to an example. What we're doing is that we give our model a prompt, which is a problem, a question essentially. We do not give him the solution this time, as we did earlier with the conversations, and since we do know the answer, we are gonna let the model try many ways to get to the answer. Some will be wrong and some will be right, like this, and this. In reinforcement learning, the AIs try to get different solutions, and in this case, 4 of them are correct. And even more important than that, these are different solutions because among these 4, for example, we know that this is better because, for example, it uses less tokens, and tokens are very expensive, and so we want to get to the correct answer with the most short and in terms of tokens solution. And that is actually it. And you may think, well, that's really simple. Trial, error, and every time I get to a correct answer, I tell you which one is the best and you learn from it. So Why is this really important? Well, an image can show you a billion of concepts. So for example, Karpathy uses in his video AlphaGo, the example of AlphaGo, which is a Chinese game. Lee is the best player of this game and is represented by this dotted line in the image. When we use the supervised learning, what was happening is that our AI model was trying to imitate a human. And what happens is that if you try to imitate a human, is that the best you can be is as good as that human you're imitating, that expert that created all of the conversation that we talked about earlier. It's only through reinforcement learning that we can allow the model to think and problem solve on their own and therefore get better than humans. This is really the only way that AIs can become more successful and think of ways in new ways that humans could never even imagine. So this graph is essentially making you understand why it is very important to do reinforcement learning for your models, because you want an AI that is actually better than some experts. But there is one problem here. We can do this only as long as we are going to work into verifiable domains, meaning in our example, we clearly knew that the answer was 3 at this problem, and therefore we were able to make the model wonder and think on their own with different solutions to get to this answer. But what if we can't really know the answer, or at least it's not verifiable that an answer is better than another one? Reinforcement learning is perfect and very good for verifiable domains like math, logic, and structured data. But how can we use reinforcement learning in areas where human intuition and creativity or humor are needed? Well, this is where we use reinforcement learning from human feedbacks, a subcategory of reinforcement learning. Let's go to an example. So now we have a prompt that is write a joke about pelicans. As we can clearly see, there is no right answer like 3 or 4 or 5, but it's an actual joke. And AI can't really tell what is humor, right? So what we are doing with the reinforcement learning from human feedbacks is essentially a sequence of 3 steps. The first is collecting human rankings. In fact, if I ask an AI to write jokes about pelicans, I can give him then different jokes about a pelican and let them rank, and the AI will then need to put a score to each of these jokes so that it can now be trained on the score that he put on all of these jokes. But since it's very hard to put a score on something so abstract like a joke, what we're going to do is to hire a human to give orderings. So rather than putting a score from 1 to 10, is to just order these, for example, 5 jokes from 1 to 5. And in this example, our human ordered this as the first most funny joke and this as the second most funny joke. As we can see, okay, so this is the AI and this is the human. We can see that both agree that the second joke is the most funny one. But if we then look at the second most funny joke according to the human, well, according to the AI is one of the, actually is the worst joke. So we know that the AI and the human have different preferences about what is the funniest joke. So after we collect in step 1 a dataset of human orderings of these jokes, we pair those with the scoring that the model gave to the jokes, and then essentially we create another dataset, but this time of comparison. A dataset of comparison from the AI humor and the human humor. In a situation like this, we know that we need to train the model so that the model can assign to the first joke a score that is much higher than 0.1 because it's indeed the second funniest joke according to humans. So in step 1, we collected these rankings from human and we essentially end up with a dataset of comparison from humans to AI model. Then in the second step, we train the reward model so that this gets adjusted according to the human preferences. And then the third step, just like we did with the normal reinforcement learning, we train the model by using this simulation rather than actual humans giving conversations. So what are the advantages of using reinforcement learning from human feedbacks? Well, I think it's very clear that the advantage is that it's much easier to just rank different outputs rather than creating a completely new one. So now we've seen the example of jokes about pelicans, but what if it's a poem? It is much easier to rank 5 poems from worst to best rather than writing a whole new poem. It's the only way to use reinforcement learning in a non-verifiable domains and therefore allowing the AI to, for example, understand ethic or morale or creativity or really anything that is non-verifiable, like humor. But there are really a lot of downsides as well. In fact, Andrej Karpathy calls this the fake reinforcement learning. That is because it is actually a simulation and can be very misleading many times. If you think about the second steps of fine-tuning, this really is much more like fine-tuning rather than reinforcement learning. In true reinforcement learning, the AI learns by interacting with the environment. Reinforcement learning from human feedbacks doesn't do that at all. It doesn't create new strategies dynamically to solve a problem. It really just optimizes based on human rankings. But still, it's the best we can do for non-verifiable domains. Now, before giving a conclusion and a summary of all we've seen today, I want to get into a very important topic, which is hallucinations. Let's start directly with an example. If you ask an AI who is Tom Cruise, it's gonna tell you who's Tom Cruise. Same from John Barrasso, same from Gengis Khan. So what if you ask who is Orson Kovacs? And by the way, Orson Kovacs is nobody. It doesn't exist. But the AI being trained on conversations like this one is not gonna tell you, oh, I don't know, or it seems like this person doesn't exist. Is actually gonna tell you something very similar to these three conversations. Essentially, it's gonna give you a very confident answer of who Orson Kovacs is, even though Orson Kovacs is a nobody. And that is because AI doesn't really know things. It doesn't know anything. It is really just predicting what is the most probable and statistically likely answer based on its training data. And sometimes, like in this case, it would predict something nonsense with a lot of confidence. So what can we do to fix this kind of hallucinations? Well, just think about it. We as humans, when we don't know something, we just Google it. So what we need to do is give the AI model access to the internet, and we can do that by using tools. In this case, the search tool. And how can we do that? Well, first we have to introduce the concept of a context window. In fact, you can think of AIs as having two types of memory. One longer-term memory, which is the knowledge in the parameters and in the transformers with the parameters, or said differently, the knowledge that the AI acquired during the pre-training. And then there is a short-term memory, or the working memory, or the context window. This is the knowledge that gets created anytime you start a new chat. In fact, when you press new chat, you are essentially erasing the context window to 0. And as the conversation with your AI goes on, then the context window gets updated. So what the tool of search does is simply when you ask, who is this Orson guy? Well, what the AI is gonna do is gonna query the search engine who is Orson. It retrieves external data from a more updated version of the internet, insert this new text just as we did in the first step in the context window, and then generates a response based on this new, more fresh data. And this is really an important concept because we really have to understand that without the tool of search, for example, all the knowledge that the AI has is in the parameters, and there is a set date. I don't know if you remember at the beginning when ChatGPT 3 came out, every time you used to ask some news, what's happening in the world right now with this and that, it used to say something, oh, my knowledge is cut off until this date. And that is because it didn't have access to certain tools like the search tools. And all the information and the knowledge that it had was in the parameters when it was trained on the internet. Now keep in mind that although there are certain mitigations tools like the search tool, these models will still hallucinate and make random errors often. That is why you should really take every answer with a grain of salt. Hallucinations happens because AI doesn't know facts. They don't know actually anything at all. It's just trying to predict what comes next based on a lot of probabilities. And that's the keyword, probabilities, which is why certain answers are perfect and amazing while others are completely random and wrong. AI and LLMs can really generate a lot of brilliance, and I really strongly suggest you to use them if you're not using them already. But beware that sometimes they will occasionally very confidently walk off a cliff. So always verify. Even geniuses have off days. Now we are to the end of the video, but first let's give you a grand summary of what we've looked look today. So first, let's recap. So let's start by going back. At the beginning of this video, we had a question. So who is this thing we're chatting with and how do they know stuff? Well, now we know that whenever we ask a question, the query is divided into tokens. ChatGPT can see this sequence of tokens and then will try to predict how to continue this sequence of tokens, essentially by giving us an answer which is another sequence of tokens. When we want to understand why exactly these tokens were chosen to be the most likely succession of my sequence of token, well, we know that that happens because of the knowledge that the AI has acquired from the internet. So why the AI is using exactly these as the tokens, as the most likely tokens that are the sequence and what comes next after my sequence of token? Well, that is thanks to the knowledge that it downloaded from the internet and has been trained on. Supervised fine-tuning then is used to make an assistant out of all this knowledge that we downloaded from the internet by making a simulation of the ideal answer that a human labeler, an expert, would give to, for example, this question that I just asked. But we also saw how things can actually change when we go from a supervised fine-tuned model to a reasoning model, one that uses reinforcement learning. For example, if you go to ChatGPT, every single model that has written reasoning is one of those models that has been trained with reinforcement learning. And if you go to one of those, then the situation changes completely. Because when we ask a question, now there is no more human labeler the AI is trying to simulate to give me what the human would give me. But instead, the AI is going on its own, thinking and reasoning and solve this problem on their own. Okay, we have covered a lot of topics into this video. I hope I explained myself well. If there is anything that is not clear, please write it down in the comments or go check out the videos from Andrej Karpathy. They are long, about 5 to 6 hours in total, but they are very worth watching and you will find them in the description. So for today as well is everything, and I guess I see you next time.